Hi, Assalamualaikum warahmatullahi wabarakatuh, and good day to all the students. This is BMM 1533 Strength of Materials class, and today we are going to learn on topics entitled Analysis on Stress and Strain Problems in Structural Members under Axial Loadings. Before we proceed with today's lecture, I would like to summarize our previous lecture, which is we have learned on different types of stresses such as normal stress, shear stress, and also bearing stress. Other than that, we also have did a revision on how to calculate the reaction forces during statics. So this is the chapter objective and also lesson objective for this subject. However, for today's lecture, we are going to focus on calculating the value of stresses such as bearing stress, shear stress, and also normal stress. So let's look at example number 5. The question asks you to find the value of the largest load P that can be applied to the bar, and all the information is given in this question. For example, cross-sectional area and diameter, as well as stress value for steel and also aluminium. And if you still remember, in our previous class, I did introduce you on factor of safety. So in this example, we are going to include factor of safety in our calculation. The first step in solving this problem is that we need to define the value of allowable stresses, because later on, this value are going to be used in solving our problems. So if you still remember, the formula for factor of safety is that for stress, for example, factor of safety equals to sigma failure dividing by sigma allowable, or sigma stands for stress, normal stress. So for this case, let's do it one by one. For sigma steel, the allowable value equals to sigma steel failure divided by factor of safety, and you get the value of 340 megapascal, or else this also known as sigma for rod AC. Same goes to aluminium. You need to substitute all the values into the formula, and from there you'll get the value of 35 megapascal, and this value of normal stresses is represent for value of stress for point B. And another part is given in the question is that shear stress for each pin in the question. So just substitute the value of the tau failure dividing by factor of safety, and from there you'll get 450 megapascal, and this one represent shear stress for each pins exist in the components. So after that, followed by free body diagram. This is free body diagram, and taking a moment at point B, because we want to find the value of P, FB, and also FAC. That's why we need to do reaction. We need to find reaction forces acting on that body. So taking a moment at point B, from there you'll get the value of P equals to 1.6 FAC. This one represent as equation number 1. After that, since there's two unknowns there, so we need to find another equation in order to solve that unknown. And taking a moment at point A, from there you will get another value of P. Equation for P which is P equals to 2.667 FB, and this is equation number 2. By looking at this information given, by right we are going to have 3 different value of P. From there we need to choose what are the suitable, which one is the suitable value for P in order to make sure that the structure is in safe condition. So the next step that we need to do is that we need to calculate the value of each P of the we need to calculate the value of a P in rod, blocks and also pins. Number 1, for rod AC, we know that the value of normal stress is given to us just now, which is equals to 340 MPa, and we know the equation for stress is that P over A or F over A. So from there we will know, we can get the value of reaction force acting on AC with the value of 106.814 kilonewton, and from here substitute this value into equation 1 just now in the previous slide, and you'll get the value of P1 equals to 170.903 kilonewton. So settle for rod AC, followed moving to block B. For block B, it is the same. Stress equals to F over A or P over A, which equals to 35 megapascal, and from there just substitute into the formula and you will get the value of AB. This value of AB you need to substitute in equation 2 in order to get the value of P2, another value of P, which is equals to 168.021 kilonewton. Another part is that we need to find the value of P exists in pins. You can choose either you want to choose a pin A or pin C. However, the location is the same and the value of forces acting on that pin, either pin A or pin C, is the same. And we know that the equation for shear stress is tau equals to V over A equals to 450 megapascal throughout our calculation in the early solution just now. And we know that this is a single shear. Please refer back to the diagram, original diagram. From there, you'll know the shear force acting on that pin is single shear. So substituting all the information in the formula, you will get the value of shear stress at pin A. And this value need to be substituted into equation 1. Why equation 1? Because we are using point C, point A and C. So it's only valid for equation number 1. Equation number 2 is for location at B. So from there we'll get the value of P, another P, which is P3 equals to 183.218 kilonewton. From there, basically we have 3 different values of P. So which one that we need to choose in order to get the correct value of P? You see, in this case, always choose the smallest value for lower stress. So if you refer to the equation of stresses, if the value of stress is higher than stress value will increase, and if the lower of forces is lower, then it will reduce the value of stresses. It's either normal stress or shear stress. So in this case, we are going to choose P2, which is equals to 168.021 kilonewton. So again, remember, always choose the smallest value for lower stress. Now, let's moving to example 6. This one includes the calculation on bearing stress, shear stress, and also normal stress. And the question been divided into 3. Number 1. Knowing that the control rod AB is to be made of a steel having ultimate normal stress of 600 megapascal, determine the diameter of the rod for which the factor of safety with respect to failure is 3.3. And question number 2, asking more or less the same question, whereby we need to find the diameter of the pin C and with the factor of safety 3.3. And in the question, it is given tau stress, shear stress with the value of 350 megapascal. And last but not least, question C, asking us to find the thickness of the bracket supports at C. And bearing stress is given equals to 300 megapascal. So how to solve this problem? Number 1, the normal step is that we need to draw free body diagram. From this free body diagram, we need to determine the value of P and also C value there. If you notice, this one being divided into C forces of C in X direction and Y direction, and therefore we need to find the magnitude of the forces acting at point C. So from free body diagram, by taking moment at point C, we will get the value of P, which equals to 40 kilonewton. Meanwhile, for reaction forces acting at C need to be divided into 2 categories, which is total forces in X direction. From there, you will get the value of Cx equals to 40 kilonewton. Following by taking reaction forces in Y direction, you will get the value of Cy equals to 65 kilonewton. After that, by taking a magnitude at location C, you get the value of C equals to 76.3 kilonewton. Then we start to use all this information to solve our problems in question A, B and C. In rod AB, factor of safety is given 3.3, and we know the formula for factor of safety is that sigma ultimate or sigma failure divided by sigma allowable, and the formula for stresses, normal stress is sigma equals to P over A. From there, we need to find the allowable stress first before we calculate another section. So allowable stress equals to sigma ultimate or sigma failure divided by factor of safety, and you'll get the value of 181.818 megapascal. After that, we know that sigma equals to P over A, and just substitute all the information that you have obtained and also given in the question. You'll get the value of A equals to 2.2 times 10 power of negative 4 m squared. And we know that A for circular members is pi over 4d square, and from there you will get the value of d for rod AB is equals to 16.737. However, for the safe to maintain its safety, we need to choose d equals to 17 mm. Now let's move on to question B. We need to find shear in pin C. Shear value is given to you with the value of 350 megapascal. And if you look at the pin itself, it suffers double shear in that pin. And therefore, you need to divide by 2 the value of forces acting on that pin. So first of all, you need to find the value of tau allowable by using the formula for factor of safety, and from there you will get the value of 106.61 megapascal. And remember again, this pin is in double shear. Therefore, whenever you want to include you want to solve the problem, please don't forget to divide the forces by 2. So in this case, we want to find the value of diameter, so we need to find the value of area first. From there, you'll get the value of A equals to 3.597 times 10 to the power of negative 4. After that, substitute into this formula, then you will get the value of DC is equals to 21.4 mm. And for safety purposes, you need to select D diameter equals to 22 mm. And why not using lower diameter? Let's say 20 mm instead of 22 mm. Well, let's refer it back to our equation, which is tau equals to P over A. Tau equals to P over A. So if the diameter is increasing, meaning area itself also high in value, this one will lead to higher stresses in that component or in that body, and therefore that's why we need to choose slightly higher value of diameter of the diameter or area for that component. We can choose either 23, 24, 25. Yeah, we can choose above 22, but then you need to remember every design includes cost. So the bigger the sizes, then the higher the cost will be. So we need to maintain as minimum as possible. Now moving to question C. The question asks you to find the value of stresses. The value, the thickness value at bearing C, and normal stress given to you is 300 megapascal. We know the question. We know the formula for bearing stress is P over TD. TD represents the area for that bracket. After that, just substitute the value into the formula, and please notice that here the bracket suffers this bracket, it has 2 brackets, and therefore the value of forces there you need to divide by 2. So from there you will get the value of A equals to 1.272 times 10 to the power of negative 6. And we know that area equals to T times D in bearing. Therefore, just substitute the value. That have been obtained from your calculation, and also information given from the question with the value of D equals to 22 mm. From there, you will get the value of thickness equals to 5.780 mm. But then again, for the safety purposes, you need to choose slightly higher value, which is equals to 6 mm. Okay, that would be all for the explanation for today's lecture. For the further understanding, I would like you to do the exercise 1 and also exercise 2. For exercise 1, answer is given to you, but then you just need to do the calculation following the steps that have been taught or mentioned just now. For question 2, no answer will be given to you, but then same steps. You just need to follow the same steps that have been explained to you just now. And those 2 questions need to be submitted but before the today's class ended. And therefore, that will be all for today's lecture. Thank you very much for your kind attention. See you again by next week. Bye.